start recording? Okay. All right, so today what I want to do is I want to run through square roots. And again, what we're going to do is we're going to review what a square root is. The lecture notes are posted also on Blackboard in the week 4 in the content section. Okay, they're already posted. So we're going to see again what a square root is. What we're also going to do is we're going to see how you simplify a square root. And we're also going to see how to rationalize the denominator of a fraction. The book, again, this is actually section P6 from the textbook. They do a lot more stuff than I'm going to do. They actually go into many different radicals, like the cube root, stuff like that. Excuse me. But I'm not going to do that for time consideration. I'm only focusing on what I think at least is the most important. Okay. And rationalizing the denominator, that will come up when well, it's good to know, and it will come up when we do trigonometry. And simplifying a square root, that has come up when I used my math lab in the past, but I still think it's good for everyone to know. All right. So anyway, first we want to say, well, what is a square root, right? We need some definitions and stuff. So here, wait, let me just check something. Just want to make sure it's not freezing. Okay, it isn't. Okay. Just want to make sure it wasn't freezing. But anyway, we want to know, what is a square root? Well, the definition now is on the slide. Basically, if you have a number b and a number a, we say b is a square root of a if b squared equals a. So if b squared equals a, then by definition, b is a square root of a. Again, that's just a definition. So some examples of that. For instance, we know that 3 is a square root of 9. And how do we know that? Because 3 squared equals 9. But that's not the only square root of 9, right? We also know by our sap and sun rules, -3 squared, negative also a square root of 9. Because again, -3 squared is 9. So it follows that 9 has 2 square roots, namely the number 3 and its negative. -3, that is. Same thing with 25, right? 25 has 2 square roots. 5 is a square root of 25, because 5 squared, what is it? Oh, I didn't put let me see if I can draw it in. Basically, because if you take 5 and square it, you get 25. Same thing with -5. -5 squared is also 25. So 25 also has 2 square roots. Okay. Now, since there are 2 square roots, we probably want to somehow distinguish between them. In other words, we say the square root. Which square root are we talking about? Well, that's where this notation comes into play on this slide here. We have this notion of the principal square root, or the square root of a, I guess. I think people usually just say the square root. It's a square root that's non-negative. I mean, if you went back to the previous slide, you would see that one square root was positive. Like for 9, you had one square root was 3, but the other one was -3 with 9 and 3. So what we do is when we say the square root, we mean the one that's non-negative, and we use this notation. So basically, this sentence is telling you what I mean by the square root. We have the square root of a, b. It's if b, we say it's the square root if b squared is a and b is non-negative. And again, this is the notation that we use, this little radical symbol, as you can see. That's notation for the square root. And the other one then, by what we saw, is the negative of it. So negative the square root of a. That's good. Also, I'll say this now, it will come up again, but hopefully it's easy to see that for a number to have a square root, that number has to be non-negative. In other words, A, right, has to be non-negative. I mean, you can kind of see it from here, because if you square a real number, you're going to either get 0 or a positive number. So A has to be 0 or positive. Just something to consider. It will come up again, but this is the notation we have. And these are just some examples here. Like, for instance, we have this notation. This is going to be 3, and that's since 3 is a square root of A. 3 squared is 9, and since 3 is non-negative. Let me just fix this notation. This wasn't on the previous slide, but the square root of 16 is 4. And again, why is that? Well, that's because 4 itself is non-negative, and 4 squared is 16. I forgot to put the 2 in, sorry about that, but I just put it in now. And for 25, same idea. So when you have this radical here, which again means the square root, you're looking at the square root that's non-negative. And this I'm just restating what I said already for emphasis. Now, I've restated this because it has helped students in the past, so that's why I'm pointing it out here. Basically, I'm saying what it means to write B equals radical or the square root of A. So, also, this symbol here that we're using, as you can see, we call it a radical sign. And what's under the radical sign, so in this case A, we call it the radicand. So what you're taking the square root of, for instance, is the radicand. So that's what this notation is telling us. Okay. All right, so again, the notes are posted. I don't want to go too slow or too fast, so let me move on. Okay, so now these are just some more examples, okay? But if you have the square root of 121, right? Well, that's going to be 11. And why is that? Well, again, that's because 11 squared is 121. In other words, 11 is a square root of 121. That's a saying. But also 11 is non-negative. The second equation here, this is not right. And why is that? Well, again, saying this is equal to -6 is wrong because the square root has to be non-negative. It can't be negative. So to fix that, we have this line down here. Namely, the square root of 36 is not -6, but it's 6. Because 6 is a square root of 36, so 6 squared is 36, and so is -6, but 6 is non-negative. So that's why this is true. Okay. And this is really what I was saying before, that when you take the square root of something, that something, the radicand here, has to be non-negative. It has to be non-negative when you take the square root of something. That's what we're saying here. Okay. You know, in other words, if I had -36 here, that wouldn't make sense. It really just follows from the definitions and really what I said, that if you square something, you have to get something that's either 0 or positive. So that's what's happening here. Okay. That's what the square root is. Okay. All right. So again, this is really, I guess, more of a review because this stuff we have seen before. I'm not done yet. But let me just move on to present some important properties of square roots. And here's our first one. Okay, not sure why this is repeated, but that's okay, I guess. But no, it's fine. But basically here, the square root of 225, for instance, right? Okay, that's going to be 15, and you can easily check a calculator if you want. But basically what happens is 15 squared is 225. So why is this equation true? Well, because of this. 15 squared is 225, and because 15 is non-negative. But if you actually replace 225 with 15 squared, so if I took this part of the equation and moved it in here, we would end up with this, as you can see. So why is this true? Again, it's just because 225 equals 15 squared. And it's the same thing with 36. Before we saw that 6 squared, if you go back to the previous slide here, 6 squared is 6. So I can replace 36 here with 6 squared. Doing so, we would get this, equals 6. And now what am I trying to say here? Basically, I'm trying to illustrate this property. That's what I'm trying to illustrate. If you have a non-negative number, you square it and take the square root, you get back to what you started with. That's really what I'm trying to say here. So basically, at least for non-negative numbers, squaring and then taking the square root, they undo each other. That's really what I'm trying to say in this case. Right, let me just let me stop the recording. So I gotta restart it.